Hello, welcome to another chemistry class with Precious. On today's topic, we are going to see how to determine the oxidation number and valency of the first 20 elements. Let's go. First of all, what is valency? We say that valency is the combining power of any element. That is to say, every element has its own combining power. Before it can join with another element and form a compound, it will come there with its combining power. And that is what we call valency. Now, how do you determine the valency of elements? Let's see some examples from the first 20 elements. Here, I have examples like helium, beryllium, oxygen, fluorine, sodium, aluminium, and calcium. Now, with their symbols and their atomic number. Now, you cannot find the valency of a particular element without knowing its atomic number. Hence, let's calculate the valency of these elements here. Helium. Helium has atomic number 2. Now, let me find the valency of helium. Come with me. Let me draw the structure of helium. This is the nucleus. And on the first shell, remember the first shell of an atom contains maximum of 2 electrons. So if I put 1, 2. Helium with atomic number of 2, it means that it has 2 electrons as a neutral atom. So if it has 2 electrons, it means this is the structure of a neutral helium. Hence, looking at this structure, you ask yourself one simple question. If I am helium, which is easier for me, to lose an electron or to gain? Remember, in chemistry, when atoms lose electron, we give them a positive charge. Hence, if you lose electron, you have a positive charge. But when you gain, when an atom gains electron, we give them a negative charge. Hence, but in the case of helium, it has a complete shell. Look at it. The first shell contains maximum of 2 electrons. So it has 2 electrons already. So it will not lose, it will not gain. For that reason, the valency of helium is 0. Automatically, its oxidation number is 0. Okay, let's look at oxygen. Oxygen with atomic number 8. Let's draw the structure of oxygen. We have the nucleus, 1, 2, so we put another shell, 3, 4, 5, 6, 7, 8. A neutral oxygen atom has 8 electrons. So, if this is the structure of oxygen, remember the first 20 elements, they obey the octet rule. The octet rule simply states that elements tends to lose or gain electron in order to obtain octet structure or have 8 electrons on their outermost shell. Now look at oxygen. It has how many electrons on its outermost shell? 1, 2, 3, 4, 5, 6. Now, 8 minus 6 is equals to 2. So oxygen needs 2 extra electrons to obtain octet structure. Now, if you are to be an oxygen atom, Which is easier for you, to gain 2 electrons and obtain the octet structure, or to lose these 6 electrons? Which is easier? Certainly, it is easier to gain. For that reason, the valency of oxygen is 2. Now, the oxidation number. The only difference between valency and oxidation number is that valency has no charge, but oxidation number has charge. So for that reason, remember I said if an atom lose electron, it takes the positive charge, but when it gains, it takes the negative charge. Now, in the case of oxygen, it is going to gain 2 electrons to obtain octet structure. For that gain, we say we give it a negative charge. How many is it gaining? 2. So the oxidation number of oxygen is -2. Now let's quickly look at aluminium. Aluminium with atomic number 13. Let's draw the structure of aluminium. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This second shell is complete, but a neutral atom of aluminium still has 3 electrons extra. So another shell will come in, the third shell. Then 11, 12, 13. So this is the structure of a neutral atom of aluminium. What do I mean by a neutral atom of aluminium? The one that has not either lost or gained an electron. So now looking at the structure of aluminium, it has how many electrons on its outermost shell? 1, 2, 3. 3 electrons. How many does it need? If you say 8 minus 3, you have 5. So it needs 5. Then ask yourself, if I am an aluminium atom, which is easier for me, to lose these 3 electrons and obtain my structure? Because when they lose this electron, they will lose this shell. So they will now have only 2 shells with complete outermost shell, which is the essence of either losing or gaining according to octet rule. So now, aluminium, which is easier, to lose these 3 electrons or to gain 5? If you are the atom that has 5 electrons, will you give somebody? So you see, it is easier for aluminium to lose these 3. And we say that when you lose an electron, we give you a positive charge. Hence, the valency of aluminium is what? 3. Because that is the number of electrons it will lose. Now, the oxidation number that will show us the charge, it lost 3 electrons, so it is +3. Now, using this same method, give me the valency and oxidation number of beryllium, fluorine, sodium, and calcium. Drop your answer in the comment section. Also, in the first 20 elements, we have exceptions. We have exceptions in the sense that these 4 elements, they don't have just one valency or one oxidation number. They have variable valency. They have more than one. And the exceptions are carbon, nitrogen, phosphorus, and sulfur. I say they have what we call what? They have what we call variable valency. They have more than one valency. And it affects their naming when they are in a compound. In our next class, we are going to see how carbon, nitrogen, phosphorus, and sulfur, how their own valency and oxidation number is and is effect. Okay, thank you. See you on my next class. Bye bye.